Welcome back. What a great chat about the future of RTC experiences, from special audio and holograms and new social experiences in playing games, watching movies together, working on projects together, playing music, singing, concert experience. Great times to be RTC developer. So thank you so much, Nitin, Paul, and Justin. Great talks, super interesting. We also have here Rahul from the hologram team joining us for the Q&A. And we have some great questions from the audience. So let's just jump to that. I will start with questions for Nitin and Rahul. So from Ross, what's the end-to-end audio and video latency currently, and what's the target?
Thanks a lot for the question, Ross. We are definitely paying attention to the latency. For a completely immersive experience, we think that the end-to-end latency for both audio and video should be in the range of 150 to 250 millisecond. But we also think it's really, really hard to achieve that in real public internet, and along with all the extra processing that we have to do for holographic calling. The current latency is definitely higher than that, and we are trying different approaches to bring it down.
From Charles, he's asking, was Draco compression considered?
I think Rahul can take that question, who is my colleague and partner in crime.
Thanks, Nitin. Great question, Charles. We did consider Draco, but three things. The Draco is really good at geometric and PCC compression for static meshes. It isn't quite clear how well it does with temporal and dynamic meshes and point clouds. Also, the compression ratios are 10 to 15x. We would like it to be more higher. And even if you were to account for those things, it is quite a departure from traditional 2D codecs. So in an RTC use case, it would be quite a challenge for us to figure out rate adaptation and error resiliency bits.
I will jump to a question for Paul. So Ashok is asking, how important is head movement to spatial audio? Wondering what level of realism can be achieved by spatial audio without tracking the orientation of the head of the listener.
Head movement is really important with spatial communications. So I'll start with virtual head rotation. So reacting quickly to rotating the head of your avatar is really important. You need the scene to change really quickly when your head rotates. You notice any lag pretty quickly, and it's a bit disturbing if you don't move it quickly or change the scene quickly, particularly in VR. And that's why we concentrate on client-side rotation, even though we do server-side mixing. Head tracking itself is also interesting, particularly if you're looking at a virtual environment and a screen in front of you. Head tracking can give you a great experience keeping the scene centered in front of you, and it can make it seem more realistic. So, head tracking and head movement is really important to take into account.
From Shinhoi, for spatial rendering, wondering if there is any space perception cue in rendering, like different room or space, different floor covering, etc.
So it's a really good question. We've played around with this quite a lot, and we did a project a number of years ago where we were kind of doing architectural rendering of voice. So you actually make the voice sound like it's in the environment that you're in. And that's really realistic. However, in sort of communications, realism isn't really what we're after. So if you focus on realism and you're in an environment with lots of glass and high ceilings, and voice can sound pretty bad. So our approach is not on realism. It's not rendering each of the voices separately in a virtual environment, getting all the reflections right. Our approach is to mix the voices. And when we mix the voices, we do it to optimize intelligibility. There's certain things you can do to make it less muddy, make it easier to understand. And then we provide room effects on the mix afterwards. And they're artificial room effects to enable you to understand what's going on. That's what we've done in the past. And we found it to be much more effective to not make it completely real.
Yeah, I'm jumping to a question to Justin. Ashok is asking, what are some examples of sub-ideal experience with traditional RTC calls for a social conversation?
I think there's just a difference in how people sort of use things for work versus how they use them personally. And like one of the examples is many of the meeting products that exist is you join from a corporate calendar. And like people don't necessarily have a shared calendar for these social events. And then once you even get into the call, the things to do there are, you can share your screen or you can kind of sit there and stare at each other. And these don't always sort of align with how people actually spend time when they do social activities. So I think, anyone who's sort of tried having like a virtual happy hour or trying to just hang out and even just talk through ideas where you normally do it around a whiteboard can just be a lot more difficult when you're trying to do it in an app that's really made for like a more formal sort of meeting in like a corporate calendar. So that's why I'm sort of interested to see some of the other apps that are exploring different ways of using real-time communication.
Shyam is asking about the idea of someone playing rhyme and another soloing on top of it is pretty cool, although the rhyme likely has to be monotonous without transitions. Curious what latency you found acceptable for co-jamming.
So orchestras typically can be large enough so that it can be 50 to 100 milliseconds between different instruments on either side of an orchestra, and then they'll use a conductor to kind of all stay on beat in that situation. But it shows you that type of latency can be acceptable to get a really high quality sound coming out. And when you take some of the other sort of approaches of you have a single rhythm and then multiple people playing melodies, which don't necessarily have to be as tightly synced, you can make things work well even at 150 milliseconds or typical sort of RTC latency. Now, I think there's opportunities to push that latency down further, into that sub 100 milliseconds, where you could get closer to what you would see with an orchestra, and then use like a visual click track or something like that to make sure everybody is on the right beat.
I think we have a little bit more time for more questions. So jumping back to Nitin and Rahul on the hologram. The next question is ZSTD being used for compression?
No, we are not using it for compression. It's for zip type encoding. And the main reason is that the compression ratio it offers is very low, less than 10x, which is not good enough for videos. We are looking for more like 50x plus, just like Rahul mentioned in his previous answer.
And which codec is used to compress the 3D video?
So we are considering different codecs right now. I had a slide which had a matrix of all the available codec options and their trade-offs. There is no clear winner right now. H.264, I think, was asked in this question, and H.264 does not have 12-bit support. HEVC 3D encoding is one of the potential candidates because it has some low-level depth coding tools, but it doesn't have silicon support. Then we have VPCC and mesh compression such as Draco. Rahul covered the mesh, the Draco trade-offs, and VPCC trade-off I covered in my slides that the time it takes for the reference encoder to encode is 30 seconds per frame, which means that in its present state, it's not very practical. So the answer is we don't have a clear winner right now in terms of which codec we want to use, but we are exploring multiple paths.
Okay, we have time for last question. So this is for Paul. A question from Sandeep. How does server-side mixing perform in experiences where the user's position is changing quickly?
So server-side mixing, when positions are changing quickly, you have to update the positions relatively quickly, like in the order of 100 to 200 milliseconds, or even 300 milliseconds is generally acceptable, as long as you get egocentric movements like rotations to be fast. That's why we split the client-side rotation to the client side, so that you can make those movements fast with 200 or 300 millisecond changes to positions in front of you. It's not particularly noticeable based on our experience.
Okay, we have a few more additional questions from the audience that we were not able to cover. We aggregated everything for our speakers. They will be able to use the chat to answer those questions. So thank you again, Nitin, Rahul, Paul, Justin. Great talks, great discussion. Thank you very much for joining us. Next coming, the AudioML session.